네, 안녕하십니까. 오늘 제조입니다. 아주 상당히 의미심장한 이 주제 두 번째 세션 제조의 현황에 대해서 앞으로 1시간 15분 동안 여러분과 대화를 나누도록 하겠습니다. 저는 사회를 맡았는데요. 새 제조업의 현황 하면서 생각이 두 가지가 났습니다. 하나는 2014년, 그러니까 재작년 6월에 유럽의 브뤼셀에 있는 유로피언 파리먼트, 유럽 국회에서 Reindustrialization, 그러니까 재산업화죠. Reindustrialization이라는 주제를 가지고 컨퍼런스가 열렸어요. 그리고 거기에 주제 발표자로 3명을 거기서 불렀습니다. 네, 한 명은 미국이었고요, 또 한 명은 일본이었고, 또 한 명은 한국이었어요. 사실 저는 한국 대표로 가서 발표를 했는데, 그 세 사람이 발표를 한 다음에 거기에 참여한 모든 유럽 국회 국회의원들 한 200명 모였던 것 같은데, 분들이 이상하게 저한테 줄 질문을 제일 많이 하더라고요. 미국이나 일본보다는. 그래서 제가 아주 상당히 곤혹한 시간을 보냈는데, 나중에 이제 질문을 했어요. 왜 미국과 일본에 대해서는 질문을 많이 하지 않고 한국에 대해서, 유독 한국의 산업에 대해서, 제조업에 대해서 관심을 가지는가 그랬더니, 그 사회를 한 분이, 그분도 이제 국회의원인데, 단적으로 이렇게 얘기하더라고요. 유럽에서는 자기네 제조업의 몰락이 미국이나 일본 때문이 아니고 한국 때문이라고 생각한다. 그러니까 한국이 가장 큰 자기네 경쟁자로 생각한다. 보니까 그 주제가 Reindustrialization in Europe인데요. 부제가 Learning from our competitors. 우리 경쟁자로부터 배우자. 그랬어요. 그리고 한국을 제일 주된 경쟁자로 본다는 거죠. 그러면서 유럽이 자랑하는 산업이 조선산업, 전자산업, 자동차 산업인데, 이 세 개를 다 한국이 뺏어갔다. 그러니까 한국에 제일 관심이 많다. 이런 식으로 한국을 높이 평가한다고 해야 될지, 제일 불편한다고 생각해야 될지 모르겠습니다만, 관심이 표적이 된 걸 봤는데, 저는 사실 답변을 뭐라고 그러냐면, 저희는 절대로 경쟁자가 아니다. 오히려 우리가 여러분한테서 지금 배워야 되는 그런 일종의 퍼스트 사이클을 우리가 지금 가고 있는 거고, 유럽은 지금 두 번째 사이클에서 지금 새로운 머처리티에서 새로운 사이클로 나가야 되는 그런 타이밍이기 때문에, 겉으로 보면 우리가 유럽의 산업을 뺏었는지 모르지만, 그게 아니라 오히려 유럽은 한국을 훨씬 더 극복한 새로운 방향으로 나가야지, 한국이 하고 있는 거를 다시 뺏어가겠다 하는 식으로 전략을 짜서는 안 될 거다 하는 그런 얘기를 드렸는데요. 오늘 사실 이 주제, 제조업의 현황을 우리가 볼 때, 단순히 그게 물량 위주로만 볼 게 아니고, 질이라고 할까, 구조라고 할까, 또는 스테이지, 사이클에서 우리는 어디 있고, 다른 나라와 어떤 사이클에서 차이가 있는가 하는 것을 함께 보았으면 좋겠다는 소박한 마음을 가지고 두 사회자, 발표자와 커멘테이터로 들어보고자 합니다. 또 하나는 중국에 관한 얘기인데요. 사실 저는 지난 6월부터 중국에 가서 지금 풀타임으로 중국의 북경에 있는 전강산학원이라는 대학에서 교수생활을 하고 있습니다. 그러다 보니까 이제 중국을 멀리서 이렇게 바라다보는 입장이 아니라, 중국의 심장 안에 들어가서 거기에서 땅바닥에 등을 대고 하늘을 쳐다보는 그런 입장에서 보게 되는데, 하지만 한국에서 중국을 볼 때하고 중국 안에서 중국을 보는 거하고 너무나 다른 거예요. 그래서 이걸 어떻게 좀 여러분과 함께 중국이 무엇인가에 대한 새로운 시각을 함께 나눌 것인가 하는 게 저로서는 제일 과제인데요. 한마디로 얘기하면 중국은 나라가 아니더라고요. 중국은 23개의 성과 4개의 특별시가 있지 않습니까? 27개의 자치구가 있는데, 27개의 나라로 되어 있는 연합국이죠. 미국이 50개의 주로 나눠 있는 연합국인 것처럼 그래서 예컨대 지금 중국의 제조업이 그 머처리티가 있어서 더 이상 한국의 생산 기지가 아니라는 얘기도 합니다만, 좀 그게 아니고 이 중국의 동쪽에 한 7, 8개 성이 그런 단계를 지났고, 이제는 그 중원이라고 그러죠. 중원 쪽으로 제조 기지가 완전히 옮겨갔고, 한 5년, 10년 후에는 이제는 서쪽에 한 7, 8개의 성으로 이 제조 기지가 옮겨가는, 중국 기업들도 요새 뭐 버마나 베트남 간다고 그러지만 아주 소수고, 한 8, 90% 이상은 그 센터 오브 그래비티, 이 제조업 중심이 지금 동쪽에서 중앙, 서쪽으로 옮겨가는 그런 흐름 속에서 수많은 성이 서로 치열한 경쟁을 하는 그런 상황이고, 한국도 이 중국 동쪽에서 지금 제조업에 대한 그 전신기지를 만들었습니다만, 물론 베트남, 버마 이런 쪽으로 가야 되겠습니다만, 지금은 중국의 중원 그리고 서쪽, 그쪽에 무한한 그런 가능성을 우리가 지금 놓치지 않아야 되는 거 아닌가. 그러면서도 한국의 제조기지와 그런 쪽의 기지 간의 그 보관성을 어떻게 지킬 것인가 하는 그런 맥락을 같이 봤으면 하는 그런 기대를 하고, 오늘 이 세션의 사회를 보겠습니다. 오늘 두 발표자가 계시는데, 첫 번째 발표자는 프로페서 데이비드 아트, MIT 교수시고 기계공학을 하시면서 최근에 그 콜라보레이티브 서플라이 체인, 사실 서플라이 체인 매니지먼트는 경영 용어입니다만, 이 콜라보레이티브 서플라이 체인, 표현이 잘 안 나오네요. 예. 이 부분에 대해서 저는 관심이 굉장히 많은데, 이걸 중심으로 해서 어떻게 큰 그림을 그려주시는지 한번 듣고자 합니다. Professor Hart, please. Good.
Thank you very much, and thank you for your invitation to be here. I'm going to talk today about a subject that's very close to my heart. It's based on my experience as much as my readings. And I really was delighted when I saw the name of this session. It gave me an opportunity to play a little bit with the word status. So often when we think about the status of manufacturing, we might talk about facts and figures, GDP, employment, and I will talk a little bit about both of those. And I think also think about technology a lot. I'm going to talk about those very briefly, but then I want to talk about different aspects. So what does the word status mean? Well, of course, probably the meaning that you might first associate with today's session is the current state of something, or the state of the art. And I'll briefly talk about that in a very broad sense, and collaborative supply chains will be a very, very small part of that. But I do want to talk about an image of manufacturing in the 21st century, because I want to get to the other part, which I actually have a greater concern about, which is status, meaning something like societal regard, or stature in the workplace, or even stature in the community. And I'll give you some interesting and I find somewhat disturbing data from the US that I hope is not true in Korea, and I know is not true in many other parts of the world, but can become so, some trends that we've seen. So if we talk about the status of manufacturing, and this I mean sort of the technological development of it, I'm going to cover 60 years in one slide. So this will be a very brief discussion to get us up to where we are now. So of course, as we know, up through the 1950s, the concept of manufacturing was very steady, stable, unchanging mass production, where you might say that manufacturing excellence meant never changing anything. In the 1960s, there had been automation all along, but in the 1960s, we started to see the emergence of a little bit more automation, and with the introduction of computing starting to reduce in cost, we saw the idea of flexible automation come in, so the idea of actually having multitasks involved in a single factory and not just mass producing of one thing. And then, actually in the 1980s, this is from very much a US perspective, learning that how we operate our factories, how we operate our enterprises became extremely important. Things as basic as quality, things as important as a good factory flow, and of course concepts such as continuous improvement, which have a technical basis but not what you'd call a high technical basis. And yet, these turned out to be the most important lessons that many corporations in the US, if not the world, learned during that period of time. If I look at the 1990s, and it's always hard to put everything in decades, but if I look at the 1990s, we have the idea that with the emergence of electronics and other consumer products where there's a high demand and a high turnover and a high market churn, you have the development of industries that can actually respond to that. How do you create a new product every year or every half year? How do you get entirely new products into a system that works like that? And this was driven a lot by the semiconductor and electronics industry, and we could argue whether that model can be used elsewhere, but it's certainly been an interesting model. Then, in the idea, my experience has been that in the 2000s, kind of moving ahead from those experiences, many companies got fairly comfortable with the ability to deliver products, new products, and to do them in high quality, and to continually reduce manufacturing costs. And then they discovered that the input and the output of their enterprise was not very efficient, supply chains being the favorite term for that. So within one of our collaborative programs at MIT, you could see the industry interest change from things like total quality management, lean manufacturing, to supply chain optimization and other things of that nature. And part of the emerging, really interconnected global manufacturing scene had a lot to do with that. So where are we now in the 2010s? There's a term we actually used many years ago at a conference we ran at MIT in our lab for manufacturing and productivity. Back probably in the early 90s, we called it rapid response manufacturing. It was a very attractive term. We got a lot of people to come to the conference. I'm not sure what any of us knew what that meant at the time, but I think we have a much better idea now, which is this idea, I think it's a thread that you heard from this morning already, that new ideas, if they don't make it to the marketplace, are not very useful. So if they end up as just a technical paper, that's not very useful. If you simply optimize a manufacturing operation to make the same old product, that's not very useful. So how do we get new ideas to the marketplace quickly? And there's some evidence, at least circumstantial evidence, that the time constant of that, despite all these things that have happened, is about the same. We haven't really done a lot to very rapidly get very new things into production, particularly if they have new processes associated with them. When we talk to a number of leading companies that are perennial collaborators with MIT and ask them about manufacturing as a key issue, they said, yes, that's an important issue, but really what is important is this time to market, this innovation to market time, and what can we do about that? So I put this forward to say that's kind of the state of the art. That's the status of manufacturing in 2015. It's real time, it's immediate, it's highly technical, and because of that, because of this inherent dependence on technology, on automation, just to keep up with global standards, you have a large capital investment involved, very typically. The clock speed, the turnover has increased, at least in terms of changing customer demands. And of course, this is a phrase we've been using now for several decades, that it's becoming much more knowledge-driven, certainly not labor-driven. And you've heard this morning that it's not an impediment to innovation, which I think many not aware of the industry might think. It's actually the source of innovation and an important partner in this whole innovation cycle. And we now really have these truly global extended enterprises that are interconnected in many different ways, through supply chains, through R&D collaborations, and other things of that nature. And two important things that come along with that is that innovations in technology travel at the speed of light. This is a phrase I heard from an adjunct professor we had at MIT, Don Clausen, who pointed out that if you have an innovation, it's essentially a piece of information. And if you put that down on paper, if you patent it, if you simply let somebody know about it, we could send that from this room to MIT in as long as it takes you to type it in your phone. But innovations in operations do not. In other words, how well you can put that all together into a system that goes from idea to product and product to consumer efficiently and continually doing that in response to the market is not something that travels at the speed of light. The other thing I would say is that the state of the art in 2015 is vastly different from the world of the 1960s, which was when at least U.S. industry in some people's minds reached its peak, if you will. I would also say that in my opinion, and if you want to raise your hand to agree with me on this, you feel free to, our educational system design, particularly at the research universities like MIT, which is the only one I can talk about really knowledgeably, hasn't changed a whole lot since the 1960s, the basic structure of it. And as Professor Fox said earlier, we still write papers, and that seems to be our most important product. I think the 1960s is when we developed that. The state of the art is that it hasn't changed a lot when we talk about professional level in engineering. Okay? So that leads me to my second part of what I want to talk about, which is the public perception of manufacturing and how we can do something about that and why, and maybe why it's that way. So Brian Anthony mentioned earlier this Deloitte and National Association of Manufacturing study that was done 2-3 years ago. I'm going to give a little bit more data on that. But as he mentioned, it basically says that if you ask the U.S. public, is manufacturing important? They say yes. If you ask them if they want to be involved in it, they say no. It's not a good career. And this is, and I think I just described a very exciting industry, a very exciting profession to be part of, and yet the perception is that you shouldn't do that. And we can talk a long time about the reasons for this, but putting a little bit more detail on what Brian mentioned earlier, this is very interesting. 86% of the people they polled said that prosperity, that manufacturing is important to their basic prosperity, most important. It's also important to the standard of living. These are very important fundamental issues for any economy. And so you're seeing people that list this as the most important or very important. And national security. It's very important to be able to produce what you need to have a secure nation. Okay, so here's the dichotomy. So you have that, and then people are asked, how qualified, in effect, are today's students for manufacturing? Now you're down to 47%. That doesn't sound too bad. Would I encourage my child to pursue a career in manufacturing? A third of the respondents said they would. And do schools encourage students to pursue manufacturing degrees? 19%. So this hits home to me and my colleagues, and maybe to all of you from the university. So I don't have an answer to this. I have, I should say, I have my own personal answers. But, oh, of course, here's the other one. I forgot this one. My parents encouraged me to pursue a career in manufacturing, 17%. That last one is very interesting because now you're talking about a generational divide, if you will, where, in fact, my father worked for a manufacturing company. I went out to that factory floor many times as a child. I was fascinated by it, but it was dirty, smelly, ugly, people working hard, they were lifting heavy things. I still thought that was wonderful, but I was just spectating. That generation that influenced my generation, and now my generation, if you're not involved in manufacturing, might be influencing your children otherwise, other than they should. So some very important things to do here. Now, one other factor, and this is a little bit far afield, but I brought this up because this happened just before I came here, and I wanted to include it in the program. As an example of how we have or haven't encouraged students to go into manufacturing, just one little caveat. But let me preface these numbers here by telling you one thing. I am right now, not today, because I'm here, but I'm teaching a class in manufacturing to our undergraduate students, a class that was designed by Professor Chun and Professor Sachs. We routinely have about 70 to 80 students per semester take this class. It's actually the only, I would say, it's the only manufacturing class at MIT. Certainly the only one that addresses what we would all agree is manufacturing. And I sat through it, not doing too much in the prior semester to learn about it, and co-leading it this year. There's an incredible amount of energy of the students there. These are juniors, seniors. They love it. They're very excited about not just making things, but learning about the real life in manufacturing. So let's take that as a backdrop now. We've got 80 or 90 of these top mechanical engineering students taking this class. They get very excited about it. They manufacture things as part of, mass produce them, if you will, design, create tooling, mass produce them, show off their products. They're very excited about it. Now we get to graduate school. And this past admission cycle at MIT for mechanical engineering at the graduate level, so this is for Master of Science or PhD degrees, we had 1,288 applications. We typically will admit 150 students from that. Of that total application pool, only 23 listed manufacturing as their first choice, as what they were most interested in. That's 1.7%. Okay? So there's something not quite compelling about that. Although you'll see that's my comment's a little bit self-serving, so stay with me. Okay, so here's some interesting data that we came across a while ago from a report that shows not just the decline in manufacturing employment, which we're all familiar with, and this has happened in all industrialized nations as it became much more productive. And the perception, of course, is that manufacturing is dying and there are no jobs. And this is the kind of data that discourages students, and maybe more importantly, their parents, from telling them to go into manufacturing. But if you parse this data a little bit and look at whose jobs are being lost, or I should say by education level, what the job trends are, here's what you find. And I'll just give you the percentages here. The curves aren't really relevant. High school dropouts, who used to be able to get lifelong employment at good pay, have declined in employment over this, I guess it's a 20-year period, 15-year period, nearly 50%. So they've taken the brunt of that decline. But even with high school, it's gone down 38%. But if you get a bachelor's degree in manufacturing over that period of time, you're up a few percent. Now that may surprise you that it's that small, but it is, at least it's growing, while all the other ones are declining. But here's to me the most interesting one, and that is that if you have an advanced degree, you're up almost 50%. Now the absolute numbers are smaller, of course, I'll show you that in just a second. But if your child is going to go into manufacturing, make sure they get an advanced degree. That's part of the lesson that you have here. And it's also an obvious result of the status of manufacturing that I just explained. It's a complex, integrated, highly technical, expensive system. And you need a high level of education just to operate it, even nonetheless improving it and creating new ones. Now here's some other data, which is actually unpublished, so I'm going to move it by quickly. But this came from Paul Osterman at MIT, the Sloan School, this came out as part of the PI study that Brian mentioned earlier. And it really just confirms what I said before, which is that you see declines in the percentage of employment, percentage of degree student employment in the below college level. It gives a better picture of the college degree level, 33% increase, but almost a twofold increase if you have an advanced degree. So different methodologies, different data here, but the trend is exactly the same. So I guess what I'm going to get at now is how well are the universities responding to this? How well are companies responding to this? There's clearly a potential there. But if I take, for example, this number here, advanced degrees, 50% increase in employment, that's where the jobs are. That's where the excitement is in manufacturing. And then I take my own institution and say, how are we doing? Say, well, 1.7% of our applicants have an interest in that area. Does that mean that there's nobody out there that wants to do that? Or does it mean that we're not offering them the right opportunity? And that leads me to the idea of the profession of manufacturing. And it's this idea that we haven't changed the way we run our universities since the 1960s. Manufacturing has had a tendency over the years to actually be a leading indicator of problems that we have, of needs, and adopter of technology even. So when computers came along, there were immediate applications in manufacturing, and manufacturing drove a lot of the developments of industrial uses of manufacturing. So I guess I'm putting forward the thesis now that what we're seeing here in manufacturing should be driving some significant reform in the university, not just in manufacturing, but across all technical disciplines. I'm going to use manufacturing because, again, that's the only thing I can talk knowledgeably about, and I think it's a leading indicator. So, what's the profession of manufacturing? What does it mean? Why do we need it? How do we create it? And why have prior attempts at doing this failed? Okay? So, let me run through these quickly. A professional degree. Well, you can look this up and see what it means. I'm going to use this following definition. It means that you have, or a profession, means that you are someone with a well-defined body of knowledge that everybody accepts are the important concepts to be aware of. It is comprehensive and multidisciplinary. It can't just be some narrow topic. You're not a specialist anymore. You're more of a comprehensive person. You're not a theorist. You understand the practical use of this. You're going to be a practitioner. And you practice in the degree program as well as the other things. You will practice in the eventual workplace. You're going to get ready to be a true practitioner. And there's some sort of association, accreditation, some way of getting together to say, yes, you are a professional in this area, independent of your employer. Okay? So is this a new idea? Well, not really. Not really at all, but it's a new idea to actually make it part of the university landscape. I don't know if it was the pleasure or the pain. It was a very difficult time, but I had the pleasure, I'll say, of helping to lead something called the Next Generation Manufacturing Study back in 1997, so some time ago. This was when I was co-director of the MIT Leaders for Manufacturing program, which I'll say more about in just a moment. This was a study that was commissioned by our National Science Foundation to talk about what the future of manufacturing would be and what it would take to be successful as a manufacturing company in the future. Basically, it was to get information from industry, and MIT was brought in sort of in its honest broker role. So most of what was developed there was not driven at all by MIT people, but by industry. And the idea was to develop a picture of success factors in the coming decades, which are now. And so we should be doing what we said if we said the right things. And for example, as Brian Anthony knows, he's heard me give the talk on this Next Generation Manufacturing program now long enough to realize that it went very interesting. When we first started to do this and gave talks on this to students, they thought this was really interesting and far-thinking. Now, if I were to get up and give a talk about this project to our current students, they'd say, what are you talking about? That's old. Everybody knows that. So that's the good news. It means that it's becoming accepted practice, except for one thing that I'm going to bring up. And that is some workforce issues that came up. Part of this was to have a group that looked at what would be the successful way of getting the best human resources for your company. And the idea came up of having independent professionals. In other words, realizing that there's going to be a lot of turnover, and that's important. How do you make sure that you have a good cadre of people who can continue to support and expand your core missions? And these are professionals that are empowered as partners in your company and taking a much larger role and actually have a sense of ownership for the enterprise, even as they kind of come and go through. So in other words, these are people that really are helping to drive the change at your company. And of course, this is something where continuous education is extremely important. So I put this up here to say that almost 20 years ago, we predicted that professional education in manufacturing would be key to success. Again, the AMP project that Brian talked about this morning, I participated in AMP 1.0 on the workforce team, and several things came out of that. I've again picked the ones relevant for today. One was improve the image of manufacturing, or the stature, or the status of manufacturing. And the other was to establish new professional degrees. And reasons for doing this, and they're very similar to what I just mentioned. So you now have sort of an older industry-based group. A much newer, AMP was primarily industry and university-based group, coming with similar directions and similar discussions. So, how new is this idea, as I said? So it's a new idea. Has anybody ever tried it? Well, one of the things that we did some time ago at MIT, quite frankly, in response to the productivity crisis in the US versus Japan, driven by a lot of industry input, was the MIT Leaders for Manufacturing program. And what this did at that time was recognize that neither our education in engineering, or that I should say our conventional engineering education, was not helping this problem. And it also recognized that one of the things that we were missing was focusing just on technology and not on how that technology worked in a manufacturing environment, how it worked in a design environment, and how it was part of the entire so-called extended enterprise. So what we did is sort of say, we don't know how to do this, and industry is having a problem, but they know a lot more about those types of things than we do. Why don't we have a true partnership here? So that was created, and it is a magnificent partnership in terms of its longevity and size, and continues to this day. And one of the things that it did, by focusing on this issue, was actually take as a key goal to simply improve the stature of manufacturing. Okay? So, the Leaders for Manufacturing has continued since then. I can give you a lot more on the history, but let's just say that it's been less than successful on some of the goals that I just mentioned. One of the reasons is that, oddly enough, it has never established a unique academic path. What we did is we combined a conventional science master's, an SM degree in an engineering discipline, with a conventional Master of Business Administration degree. It's convenient, but it doesn't really define anything new. And as that has happened, what's actually happened is, at least in the US, the MBA has a higher stature than a master's degree, and maybe even higher stature than a master's degree in manufacturing. And so what has happened over time is it's become essentially an MBA degree with a little bit of engineering on the side. There's some great advantages to it, but it hasn't really created what I call this push for a new profession. It did respond to short-term industry needs and continues to respond to short-term industry needs. So it's kind of lacking in a longer-term perspective on it. And they've tended to go for the latest crisis. What's the biggest problem in industry this year? And if you look at the themes over the years the program's been around, you'll see them sort of either leading or quickly following some of the latest ones. And it's become more important for recruiting MBAs with an industrial flair than anything else. And the last one is, and we talked about this morning too, it's really only been for large industry players, and it's been difficult to get the smaller medium enterprises involved. And so, as I said, it never developed this unique one. All right, full disclosure here, I'm now going to tell you about a program that, along with Jungwon Chun and Brian Anthony and several other colleagues at MIT, we created about 12 or 13 years ago. So all objectivity is about to disappear. I'm going to tell you about it and why it's so wonderful. Not entirely true. But because of this experience and opportunity, we decided we would try a new path at MIT, which was to create a unique degree, unabashedly focused on manufacturing, that was not a research degree, and that's an unusual thing at a place like MIT. It's not an MBA, and it has, rather than, as we do in most of our research degrees, just give students a smorgasbord of classes to go to and say, here, take 3 classes here and 4 classes there, and have a nice time taking classes. We came up with a highly integrated, comprehensive, well-defined set of classes that define the knowledge that we wanted the students to work on, with a clear focus on innovative manufacturing. So it's got a very strong focus on what we want to do. And it's got an emphasis on practice and leadership and innovation. And that doesn't mean that we're looking backward, but what it means is that we take students who've already got good technical fundamentals and basically help them learn how to use it in a very short period of time. Okay, so I'll go through this quickly, but some of the key things about it are that it's non-research degree, it's comprehensive. The students go through as a group, as a cohort. There's a real partnership amongst the students. It's an emphasis on using engineering as the background, as opposed to the business administration. We introduce a systems perspective to the students, and it's strongly project-based. So students do a lot of projects in teams as they go through, and a very strong industry connection almost from day one. And it's only 1 year long. Okay. So it has a core curriculum, as I said, that's sort of prescribed, but just to give you an idea, to put a little bit more meat on these bones, is to say that we have 4 areas that we think represent this core knowledge. One is what I call manufacturing physics. It's probably what we would think of the technology, the materials, the tools, other things like that. Manufacturing systems, which is how they all work together in a factory and in a supply chain. Product design, so how the development of new products interfaces with manufacturing and how that's influenced. And some basic business fundamentals, language of business, so that they can understand financial aspects of the business and some of the organizational aspects of it. And then we put on top of that foundation a concept of teamwork and a group project. And this is completely, I should say, is completely different from what a typical master's degree in the research curriculum would be. Okay. But is this enough? Okay, well, what we find is that highly talented students are coming to this. In other words, what we're finding is there are people that want to do this. We've tapped into a new resource, and these are not people who are choosing between this and a research degree. They're saying, no, if this degree didn't exist, I wouldn't be going to graduate school. These are students where they've already developed a high passion for manufacturing. And we've also found that the graduates hit the ground running, and so they start to add value to their employers right away. So we kind of ask, what is their status? Well, it's not clear that our one little program, and it is a little program, has yet defined a profession, and we can't do it simply by admitting students, educating, and sending them out. Employers have recognized this in our students. The reward is measurable, but it's not huge at this point. Maybe more importantly, my university does not recognize the value of this in the following sense. And maybe I'm asking too much too soon. But this does require an entirely different way of thinking about what is excellence and why having programs like this is important. And so what I'm really going to end up with then is say that because of those 2 points, let me end by saying I have a message to industry, and that is to think beyond conventional concepts for manufacturing. Don't think of it as just a collection of technologies, or just, oh, it's just operations management. It's really all of those, plus it's a resource for innovation. And what really makes all of this happen, as you know from your own businesses, is the pull. So creating the pull for these professionals. I've given you one example of what that might be, but creating a pull for those is the key for this to really happen. And so partnering with leading universities to create programs like this, insisting on it rather than taking the generic product that is now there, and then also providing financial support for the best and brightest students to do this. This is a very good way of improving the status of manufacturing in students' minds and within companies. The message to government is that you have to realize that those jobs that disappeared for the people without high school degrees or with high school degrees are never coming back. And that manufacturing is not, and it's been mentioned already this morning, it is not itself a huge job producer. It will continue to produce jobs and be fundamental to the growth of the economy. But that's not why we do it. It's a major source of stable economic activity with, as mentioned again this morning, tremendous secondary impact. And it's a sophisticated enterprise that's very important to the global competitive environment. And I think this came up as well, I think maybe in Brian's talk, global companies will know where the best talent is. That's a very well-known lesson. So, to make it hit home, speaking to myself and other academics in the audience, understanding the value of education, advanced education in practice is extremely important. That it's not worse than research, it's not better than research, it's the same as research. It's very important to producing the kinds of educated professionals that we need in the 21st century. As I said, what I'm talking about today is manufacturing specific, but I think it could be expanded to many other areas as a new model for engineering education. Universities should be reaching out to support industry partnerships to help in doing this. And really hard one here is how do you encourage faculty to orient their careers in this direction? Why do we do so many papers? Why do we only write papers? Because that's what we're told to do. That's what the university wants us to do. That's our most important measure. If we at the university start talking about other measures that are equally important, this could have a huge impact in this area. And finally, I'd say to the universities, get out of the 20th century. Thank you very much.
Thank you very much, Professor Park. 자, 두 번째 발표는 우리 한국개발연구원의 최문중 박사십니다. 저 박사님은 그 거시경제주에서도 경쟁력을 많이 연구하셨고요. 최근에는 그 산업서비스 경제연구원부장으로 제조 쪽에 깊은 연구를 하고 계십니다. 자, 최 박사님, 부탁드립니다.
네, 안녕하세요. KDI의 차문중입니다. 저는 오늘 국제회의가 이렇게 우리말 프렌들리 할 줄 모르고 영어로 파워포인트를 준비를 했는데 영어로 파워포인트를 준비하고 한국말로 하는 게 제일 어렵더라고요. 그래서 잘 못하지만 일단 영어로 하도록 하겠습니다. Good morning, ladies and gentlemen. My name is Munjung Cha. I'm from Korea Development Institute. I'm a PhD in economics, means wrong kind of doctor in this room. And Still, I think it's really interesting opportunity for me because I can exchange my ideas and views with people, experts from different fields. Well, this is the last presentation in the morning, I think, and you must be tired. I always ask myself, who would be more tired, speaker or audience? And my answer is always audience. And I have a lot of empirical evidence. I have never seen any speaker falling asleep during a speech, but I have seen a lot of people falling asleep when they are audience. So in order to keep you awake, I think I should move around. So this presentation may be more labor-intensive presentation than the prior 3 presentations. Well, I was mandated to have a presentation about Korea's manufacturing today. And actually the whole title of this conference is Future of Manufacturing. So my presentation may be a little boring compared to the other presentations, which are very well fit to the general title of this conference. But as I was mandated like that, I will concentrate on the current status of Korea's manufacturing, starting from sorry, probably this is not the made in Korea. Move. I introduced the Korean economy in general first, and then I'll move to the Korea's manufacturing sector. And then we can see this manufacturing from some other point of view. We call it global value chain. So using global value chain, I would like to reevaluate the Korea's manufacturing sector, and then I will move to R&D, productivity, and these kinds of things for manufacturing. But we can see a lot of rosy pictures up to that time, but actually we have very serious problem in our manufacturing. So we will see them in the next chapter and then investigate more about challenges that we are facing, and then I wrap up my presentation today. Right, the first one, the Korean economy overview. As you know very well, the per capita GDP of Korea was only $87 in 1962, but in just one generation's time, we broke through almost $30,000 of per capita GDP. And during that time, our economy also experienced a structural change. So about 40 years ago, 50 years ago, we could produce only potato chips. But nowadays, we are producing computer chips. Or some people say that from chips to ships. Now what about growth rate of Korea? If you look at the annual growth rate of Korea from 1970, you can find that, number one, they are really high. Number two, they are declining. And number three, they are keeping declining so far, right? And you can see very easily that in every 10 years' time, the average annual growth rate of Korea is step by step decreasing. So probably somebody killed Korean economy gradually or softly. And what about future? If we forecast growth potential of future, it's not rosy at all. Nowadays, we estimate that the growth potential of Korea is just about 3.5%. So in fact, our economy is currently doing our best. Our annual growth rate is about 3.5% or 3.7%. And in fact, that is very close to our potential growth. Now, why is it? Because we have a lot of problems, in fact. Number one, our investment is declining. Number two, the fertility rate is very low, and the working population is decreasing. And number three, we have more and more aging people. And our productivity or innovation is still stagnating. Because of these reasons, we forecast that our growth potential will continually decrease in the future. Right, this is the overall figure of Korea's economy. And what about Korea's manufacturing industry? Korea's manufacturing industry has been growing very fast, and it has been performing really well, at least in its figures. The left one shows that the GDP share of manufacturing has been increasing over time. The manufacturing here is the red one. And if you look at employment share, manufacturing's employment share is actually decreasing very fast. So if you look at last year's figure, about 18% of workers are employed in manufacturing sector, but manufacturing sector also explain about 30% of total value added. So 18% of workers produce 30% of value added. It means that manufacturing is doing very well, or other industries do not perform really well. And service is actually the sector which is very problematic. If you look at the value-added employment with other countries, compare other countries with other countries, Korea has highest value-added share of manufacturing among OECD countries. So Korea is very much manufacturing-oriented economy. And that point is employment share. So you can find that in case of Korea, employment share is about the average or slightly higher than OECD average. However, Korea's value-added share of manufacturing is definitely highest among OECD countries. The below one, that's about service, Korea, bottom among OECD countries in terms of value-added. What about composition of manufacturing in terms of value-added then? If we go back to the 1970s, the labor-intensive light industries explain about 60% of value-added, and the remaining 40% was explained by heavy and chemical industries. But if you look at 2013's figures, the light industries explain only 13%, and 87% of total value added in manufacturing was produced by heavy and chemical industries. So we can find that the country moved very fast from light industry to more heavy and chemical industries. And this one is more dramatic if you use some very simple index called the Hoffman ratio. Hoffman ratio is value added from light industry divided by value added from heavy and chemical industry. So if this figure is higher than 1, it means that the economy is more oriented toward light industry. If it is lower than 1, the country is more oriented toward heavy and chemical industry. And if you look at the UK, that is top here, in 1840, the Hoffman ratio for UK was 5, and it took about 140 years for this country to break through 1. And this period is reduced when Japan transformed from light industry-oriented economy to heavy and chemical industry one. It took about 45 years for Japan. If you look at Taiwan and Korea, it took only 20 years. So in 20 years' time, we moved from light industry-oriented one to very heavy and chemical industry-oriented one. Then, who are the leading industries in Korea's manufacturing? If we pick up top 10 industries in Korea, manufacturing industries, they are automobile, shipbuilding, general machinery, communication device, steel, metal, etc. The interesting thing is that these top 10 industries explain about 80% of Korea's total facility investment and about 75% of total export, 70% of production, and 70% of value added. So we can see that these top 10 industries explain the huge part of the Korean economy. And what about export composition of Korea's manufacturing? If you look at 1970, we have some electric exporting goods and machinery and transport, steel, and 73% are actually all light labor-intensive goods. But in 2010, petrochemical, electric and electronic, E&E, and machinery and transport, they explain about 80% of total export. So there was huge change in the composition of exporting goods in Korea. If you look at this in detail, if you pick up the top 10 exporting products from Korea in 1961, as you can imagine very well, they are iron ore, tungsten, raw silk, anthracite, all the primary products. But in 10 or 20 years' time, all of them moved out, stepped down from this top 10. And many of them are light industries. But in 2014, last year, the winner, the semiconductor, petroleum products, automobile, marine structure, wireless communication. These blue ones are so-called E&E, electric and electronic. These red ones are transport equipment. And then we have some petrochemical. So we can see that our economy is very much oriented toward producing heavy chemical industries, especially three things: petrochemical and transport equipment and electric and electronic. So they are explaining the significant portion of production and export. Now, if we look at this one from global value chain point, so now we are looking at value added, not just the total nominal amount. In this case, if we pick up transport, petrochemical, and E&E, the total export ratio of these three industries reach about 66%. So 66% of our total export came from transport, petrochemical, and E&E. The service sector explained only 14% of total export. It is very low. However, if you look at value added instead of total export, then these three industries explain this figure is wrong. It must be 43%. My primary school was not really good. I made a mistake many times. It should be 43%. So these three industries explain 43% of total value added. And interestingly, service sector explain 35% of total value added export. So in fact, service sector is playing a very important role too. However, many times they are used as ingredient of manufacturing goods, like legal advice or design and this kind of thing. So we can find that actually they perform really well, but if you look at value chain, if you look at value added, they'll be smaller, but this is not a bad news. Actually, this is really good news because it means that these industries are very well advanced, very well participated in global value chain, and they pick up something very cheap but high quality from overseas, and then add our own value added, make a final good and export them. So this is actually good news of globalization. This is a bit complicated. Let me skip this part. So if we check who really got the benefit from global value chain, so involved in export and import, some industry can make a lot of benefit, some industry may lose something. The answer is that the manufacturing sector collect benefit from this kind of global value chain over time. In contrast, service sector has been losing. So we can find that service sector has some kind of problem. It does not have sufficient capacity to add value added in the Korean economy, but manufacturing sector has been performing really well so far. And now we are interested in productivity, R&D, and competitiveness of Korean manufacturing firms. This one has been discussed already, right, in the morning. This is gross expenditure in R&D in Korea as a percentage of GDP. So we can find that the GLD ratio has been increasing consistently, and nowadays the significant portion of this GLD is actually from private sectors. So government is playing some role. However, that role is relatively small nowadays. The number of researchers in R&D also increased very fast. So this is really good news. If we have international comparison, the left one is GERD ratio for many OECD countries. Korea, blue one. You can find that the GERD ratio out of GDP has been increasing the fastest in Korea. And in terms of GERD GDP ratio, this is the highest in the world. So in the morning, Professor Park said that this is true, but it has a lot of problem. I completely agree to him. A number of researchers divided by population. In case of Korea, also including the fastest pace in the world. And nowadays, it is one of the top, together with Sweden. So in terms of expenditure and number of people, we are okay. And in some sense, we got some fruit out of this kind of effort. This is number of patent application to WIPO. And Korea is now ranked as number 5. Next to USA, Japan, Germany, China. And I think, for the time being, this is the best ranking for Korea. We cannot surpass China or Germany in a very short time. And even in trial patent families, actually Korea is performing really well. I think Korea was ranked as number 4 last year. But the problem is, the commercialization rate is very low, right? And we spend a lot of money from the taxpayers' money, but they are not very effective in many cases. This is a problem of Korea's R&D. We have good R&D output, and we got pretty good education system. We invested a lot for manufacturing sector, and we have this kind of outcome. If we're using GDP in purchasing power parity, so this is a bit tricky. If you're using purchasing power parity, then Korea's manufacturing sector produced $112,000 last year, or year before last year, while the US produced $134,000. So if you make it 100 for Korea, the US is 119. So Korea is about 20% lower. Korea's productivity in manufacturing sector is only 20% lower than that of the United States. What about service? When Korea is 100, the United States 200. So Korea's service sector has labor productivity of 50% lower than that of the United States. But good news is that if you're using purchasing power parity compared to other G7 countries, labor productivity in Korea's manufacturing is pretty good. And this one shows how Korea's labor productivity in manufacturing increased over time compared to G7 countries. As a result, when UNIDO published so-called CIP score and CIP ranking, that is competitive industrial performance index, Korea was ranked as number 4 for quite a long time. And we are just next to Japan, Germany, United States. I don't think this index is really perfect. However, the result is beautiful anyway to us. Right. Then let's move to very serious part from now on. Here we have many dots. They are actually top 10 industries in Korea. And x-axis is market share of Korean industries. Y-axis is market growth rate. This kind of analysis is frequently carried out by consulting firms like Boston Consulting or Deloitte or McKinsey. If you use that framework and look at the change of Korean industry's position over time, the black ones are 1997 position, and red ones are the first half of 2000. Communication device was here in 1997, moved down here. So it means that the global market growth rate of communication device was decreasing, but Korean industry is increasing their market share dramatically. It means that even when the environment is a bit adverse, still Korean industries did their best. What about semiconductors? The world growth rate decreasing, and Korean industry's market share also decreased in this period. So you can find that they moved in this way, they moved in this way. Sometimes they do not move a lot, they moved in this way. So it means that oil refining and steel, the global market growth has been increasing, and Korea's market share actually decreasing. Now, what is the best movement for Korean firms, Korean industries? It must be north-east. The market should grow very fast, and Korean firms should increase their market share. that is the best one for Korean industries. However, we do not have any industries moving in that direction. We always move in some other directions. Then what about after that, from the first half of 2000 to about 2010? If you look at this figure, that is more interesting. Oil refining moved down from here to here, steel in this direction, semiconductors, this direction, petrochemical, automobile, machinery, metal, all of them moved to southeast part. It means that the world environment is getting worse and worse. However, Korean industries are doing very well, right? It seems like that. However, probably we can test this kind of question as well. We did our best, but was it really our best? Can you ask this kind of question? Why couldn't we move to the other direction? It means that, what I'm saying is that the Korean manufacturing sector probably could not find the right direction of movement. There must be some industries where the global market increased very fast. However, Korean top 10 industries always stay there and try to increase their market share in the declining industries. Now our question is, how we have to move in the northeast direction, try to find blue ocean and increase market share in these industries. Bad news for Korean firms. If you look at the marginal return to investment, it has been declining for Korean firms. If you look at the marginal productivity of capital, it has been declining from 1970 continuously like that. If you look at the loan asset ratio of Korean firms, recently they started to increase. And if you look at growth rate of sales, assets, and profit, all of them started to decrease. So we just feel that this is kind of a deja vu of just before the 1997 Asian financial crisis. The manufacturing sector of Korea faced this kind of environment in the first half of the 1990s. And the service sector's inefficiency added more worry on this. Service sector's employment increased like that, manufacturing sector almost stagnated. However, in terms of relativity, the share of labor in manufacturing sector has been declining. If we compare value added per capita in service sector and the value added per capita in manufacturing sector, in the 1990s it was 170. It means that service sector was 70% more productive than manufacturing sector in 1990. However, that ratio has been declining very fast. And about late 1990, now the per capita value added in manufacturing surpassed that of service sector, and these days it's about 50. Means that service sector is only 50% of this. Service sector's productivity is only 50% of that in manufacturing sector. So this one is a big problem too. If you compare service sector's productivity evolution compared to other OECD countries from 1991, for most countries, the service sector's productivity compared to manufacturing sector has been declining. It means that still manufacturing sector has a lot of innovation and increased value added and productivity. However, Korea's declining productivity is just stagnant here. So there is a problem of Korea's service sector in contrast to the manufacturing sector. Another problem of Korean manufacturing sector, the larger firms' production increased very fast. Small and medium-sized firms, they could not increase very fast. And if you look at the wage level of workers in large firms and small firms, this order is exactly same as the size of the firms. So as you are in the larger firms, you get higher wage. And if the size of the firms is declining, then the wage level is declining in general. I think this is the most important problem to the Korean economy. This is kind of symptom of atherosclerosis of the Korean economy. This one shows the average size of startups in Korea. In 2001, the average size of employment in startup was just below 10. 2002, slightly decreased. 2004, decrease. This is no more problem. The startups in Korea, very small size. It's good in some sense. We have a softization of the economy, so idea is more important. But still, too small companies is not really good. But the more important problem here is that over time, their size does not increase very fast. So we have quite a large number of new startups, however, they could not grow. So we have a big problem of 동맹경화. Our channel to introduce new ideas, technologies, and dynamics, they are all blocked because we have relatively fewer new startups and they don't grow very well. Challenges. Well, I'm not supposed to talk about these challenges because what I have to say is just the current status. But still, I want to say something. Entrepreneurship of Korea declined very fast, even lower than United States nowadays. It was one of the highest in the past. However, now it's not. Law and order unestablished in Korea, social capital is always short. It means that it's very difficult to have creativity, expect creativity or innovative ideas in this society, and transaction cost is always very high. And regulation level is very high in Korea. This is another problem. Only a few countries in OECD have a higher intensity of regulation compared to Korea. From government policy side, this one is very important. We have a lot of zombies in our economy. Here, zombie firms, it is defined as a firms who cannot pay their interest with their profit. This is defined as a zombie. They make a deficit. If you look at Korean manufacturing in 2013, 10% of Korean firms are zombies. This is really serious for transport because about 28% of them are zombies because of shipbuilding industry. Construction, not manufacturing, however, this is really serious, right? 40% of construction companies are zombies. They cannot pay their interest. Government helps them survive in the economy. This is a really big problem. Government uses three kinds of policy measures: interest subsidy and rollover of debt, or combine these two. And these firms, they got subsidized like that by the government, and they survive. And why is it a problem? As they survive, exit ratio is declining like that. So bad firms do not exit from the industry. It means that it's very difficult for new firms to get into this industry. There always lack of capital and labor. And this one shows that as the share of zombie firms increase in some industry, the employment growth rate decrease. As the share of zombie firms increase in some industry, the investment growth rate of the industry decrease. So this kind of, an existence of this kind of zombie firms, they hurt employment growth and investment growth. And about polarization in R&D, top 10 companies, not industries, top 10 companies has about 50% of gross expenditure in R&D. And top 10 companies employ about 30% of researchers, and they employ about 45% of PhD researchers. So there's big discrepancy between the innovation capacity between large firms and small firms. Right, I think it's almost the end of the presentation. So what should we do? I think the speakers in the following 3 sessions will talk about the future direction of the Korean manufacturing. But if I very briefly speak about that, number one, we have to explore new frontier like IT, BT, and T. And number two, we have to deepen our competency in the already existing flagship industries. Like automobile, we introduce intelligent automobile, intelligent vehicle, and shipbuilding, we can introduce more high-value added ships. By doing that, we can increase our competitive edge. And number three, very interesting one, Sovietization of the manufacturing is very important. Because even when we are talking about innovation in manufacturing sector, actually innovation happens where they use IT or something like that. More service software ideas are introduced to manufacturing, and we have new innovation. So manufacturing's innovation source is many times service. So we have to understand the importance of service, and then try to combine service and the manufacturing. In that sense, we have to emphasize 3 C's: connectivity, creativity, and convergence. With these 3 things, we can revive our manufacturing sector. Last one, I told you 3 C's, but actually there is one more C, that is China. So connectivity, creativity, convergence, and China. We all understand the importance of China using very simple macroeconomic model. If Chinese, this is GDP, I'm sorry, this is not growth. If China's GDP decreased by 1%, then Korea's GDP decreased by 0.17%, including direct and indirect effect. Now China is using kind of expansionary investment policy, but if they reduce their investment by 6.5% point, it means that China's investment level go back to the before global financial crisis level. If China use this kind of policy, then Korea's GDP growth will decrease by 0.8% point. So we can find how important China is to Korea, and we have to look for a kind of, rather than just competition, more collaboration and complementary relationship should be explored to get along with China. Thank you for your attention. This is the end of my presentation.
네, 감사합니다. 저희가 한 5분, 6분쯤 늦게 시작했기 때문에 그만큼만 시간 드리겠습니다. 자, 우리 코멘트 해주실 홍지욱 선생님은 현대자동차의 브레인이십니다. 그래서 자동차산업연구소 소장 겸 부사장으로 가장 중요한 우리나라의 자동차 산업 이끌어주고 계시는데요. 코멘트 해주시죠.
네, 차 박사님이 오디언스가 가장 힘드실 거라고 말씀하셨는데 점심시간이 다 돼서 이거 하는 거는 힘든 정도가 아니라 잔인한 생각입니다. 간단히 좀 말씀을 드리겠고요. 제가 이 코멘트하는 거는 좀 하트 교수님에 대한 코멘트는 제조업 종사자로서 그리고 공대 다니는 딸을 둔 아빠로서 제가 공감하는 게 좀 아주 많이 있어서 간단하게 말씀드릴 질문 한 가지만 제조업의 그 현상에 대해서 말씀하시는데 한 100년의 역사를 간단하게 정리하시는데 제가 가장 좀 깊게 들었던 것은 사실은 그 이노베이션 투 마켓 말씀하셨는데 지금 그 한국의 제조업 기업들이 가장 필요로 하는 어떤 역량인 것 같습니다. 지금 타임 투 마켓 부분은 상당히 많이 캐치업이 됐고 거의 유사한 수준으로 올라가겠지만 이노베이션 투 마켓 부분은 아직 갈 길이 굉장히 멀다. 이 정도만 제가 말씀드리고요. 현대차의 경우도 지난 2000년 이후에 저희가 아주 빠른 속도로 성장을 했고 캐치업 단계는 거의 끝났다라고 지금 판단이 되지만 이제 앞으로 선도형 시장을 선도하는 선도형 성장 모델로 전환을 해야 되는데 가장 필요로 하는 부분이 지금 이노베이션을 가지고 혁신 전략의 역량을 어떻게 구축할 거냐 가장 중요한 과제가 된다 이렇게 말씀을 드리겠습니다. 그다음에 제조업의 경제적인 중요성 이거 제조업 종사자로서 당연히 가슴이 아닿는 이야기고요. 우리나라 관련돼서 좀 말씀드리면 제가 제조업 종사자로 가장 가슴 아프게 생각했던 거는 아주 저희가 이렇게 제조업에서 굉장히 강국이 되어 있지만 사실 한국 사회에서 제조업에 대한 그 패배주의가 적지 않게 존재해왔다. 예를 들어서 80년대 저희가 중화공업화 비프시가 끝나고 난 다음에 그 위기 상황에서 한국에서 자동차로만 해도 그렇습니다. 그때 어떤 생각을 했냐면 이건 한국에 맞지 않다, 비교 이론이 맞지 않다고 생각하고 이걸 해외 그 자본 외국 기업에 넘겨야 된다는 그런 그 정책들이 있었고, 뭐 가깝게는 한 15년, 뭐 16년 전이지만 IMF 위기 때 나타났던 자동차 산업의 그 관점들, 그리고 한국에서 그 한때 2000년 초반에 IT 그 붐이 일적에 소위 뭐 신산업이라는 거하고 굴뚝산업을 분리하면서 그때 나왔던 그런 제조업에 대한 그 이야기. 최근에 이제 나온 이야기들이 이제 중국과 관련돼서 이렇게 또 이야기들이 나오고, 그렇지만 한국 제조업은 상당히 그 강인한 생명력을 가지고, 제가 볼 때는 60년대, 70년대 산업화의 가장 중요한 저희가 간직해야 될 자산 중에 하나가 바로 이 제조업 부분의 경쟁력하고 그 경쟁력을 지금까지 끌고 왔던 대기업의 어떤 그 강인한 생명력이라고 이렇게 생각을 합니다. 그래서 이런 부분에 대한 사회적 인식들, 특히 그 정부 사이드에서 그 정책 당국자들의 인식들이 그 대단히 저는 중요하다는 말씀드리고요. 그리고 그 이와 관련돼서 제조업의 사회적 이상에 대해서 말씀하신 분들, 그 똑같은 서베이를 한국에서 일반 국민들을 대상으로 제조업이 얼마나 중요하냐 이런 거 한번 그런 조사들이 돼 있는지 모르겠지만 제발 미국보다는 좀 높게 나왔으면 하는 바람이 좀 있고요. 그리고 제가 아주 이건 미국이나 한국이나 비슷하구나 느꼈던 거는, 제조업체에 종사하는 사람으로서 저도 사실은 공대 다닌 딸이 있지만 가끔 그 생각합니다. 이 친구를 제조업으로 가야 되는데 아니면 공장으로 보낼 수 있겠느냐, 내가 이 생각을 제가 가끔 이렇게 할 때가 있습니다. 굉장히 어려운 환경에서 어떻게 보면은 있다고 볼 수 있는 거죠. 좋은 인재들을 저희가 뽑아서 한국 제조업이 그렇게 중요하다고 말씀하시고 지금 이노베이션이 중요하다고 하지만은 얼마나 좋은 인재들이 제조업적으로, 뭐 제가 지금의 뭐 대학 입시에 대한 말씀 더 이상 안 드려도 잘 아실 거기 때문에 그런 부분들 저희 굉장히 걱정이 많습니다. 우수한 공대 출신들, 그리고 과거에 현장에도 우수한 그 공고 출신들도 있었거든요. 근데 이제 이게 세대가 이어지지 않는 가능성도 있다는, 그건 다 아시는 이야기지만 정말 현장에서 뼈저리게 느끼는 이야기이고요. 그 다음에 그 제조업의 기존 컨셉을 바꾸라, 이거 굉장히 공감하고 있습니다. 제가 그 공대 출신 엔지니어들한테 갖는 가장 큰 불만 중에 하나고요. 자기 기술밖에 모르고 이걸 통합적으로 보는 사고로 되어 있지 않고, 그 다음에 시장의 흐름에 대해서 모른다는 겁니다. 잘 모른다는 거죠. 시장과 기술이 어떻게 함께 가는지 이거 이해할 수 있어야 된다는 말씀 좀 드리고요. 그다음에 그것 관련돼서 지금 인재 육성에 대해서 말씀을 또 하셨는데, 그 기술 초점이 아니라 오퍼레이션 전반에 대한 이해가 있어야 된다. 정말 와닿는 이야기가. 좀 반대로 이제 그 우리 조동준 경영대 뭐 교수님이지만 경영대 출신들 반대로 제조업에 대한, 기술에 대한, 오퍼레이션에 대한 학습이 돼 있어야 된다고. 한국이 어떻게 보면 학제 간의 그런 이 융합이라는 게 정말 필요한데, 그래서 지금 MIT에서 뭐 지금 시도하고 계시는 그 프로그램이 상당히 저는 기대가 크고, 개인적으로는 제 딸도 한번 보내볼까 하는 생각을 지금 잠깐 했었다는 말씀드리고요. 이와 관련돼서 제가 현장에서 근무하면서 바라는 것 중에 하나는 공대 출신 CEO가 많이 나왔으면 하는 생각. 특히 제조업은 공학적 지식이 없이 CEO가 된다는 건 저는 위험하다고까지 생각을 해요. 저는 경제학 전공자지만 근데 그 공부하기가 쉽지가 않더라고요. 그 공학적 지식을 획득하는 게 쉽지가 않아요. 근데 그만큼 기회가 있다는 이야기입니다. 앞으로 한국 제조업이 이보다 훨씬 더 계속 지속적으로 성장하는 데는 공대 출신 CEO들이 정말 많이 나와야 된다는 게 제가 가진 생각입니다. 그렇게 하기 위해서는 우리나라에도 이렇게 그 생산이나 제조 과정 전반적인 프로세스를 이해하는 거, R&D부터서 또 제조 과정, 판매까지, 시장까지 이해하는 이런 그 교육들이 현장에서 좀 이루어졌으면 하는 말씀을 좀 드리고요. 그 차문중 교수님 발표 관련돼서 아까 제가 간단하게 말했지만 현대차뿐만이 아니라 한국 제조업체들이 상당수의 상위 그룹에 속하는 기업들이 이제 그 캐치업에서 이제 선도로 나가야 될 이런 과정이 있고, 그 역량을 확보하는 게 제가 현장에서 느끼는 거는 굉장히 어렵습니다. 이걸 어떻게 해야 되느냐? 이게 기업만의 힘으로 될 수 있는 것인지 아니면은 정책 그리고 아까 그 사회적 인식에 대한 말씀도 하셨지만 그런 부분의 그 의식들의 변화들이 상당히 뒷받침이 돼줘야 된다라고 생각하고 특히 그 여기 계신 분들도 그 자녀분들 학교 가신다면 좀 공대 많이 보내주셨으면 하는 말씀 드리고 그 제 코멘트는 마치겠고요. 아까 그 제가 하트 교수님한테 질문하는 가지 하겠다고 했던 거는 발표 내용 중에서 그 인디펜던트 프로페셔널에 대해서 말씀하셨는데 그게 그 제조업 현장에서 구체적으로 어떻게 활용될 수 있는지 사례가 있으시면은 좀 자세히 좀 설명을 해주시면 저한테 도움이 많이 되겠습니다. 고맙습니다.
1 minute answer by Professor Hart.
I was afraid you were going to ask that question. It's a very interesting point, and I think right now it's more of a model than something that actually exists. But there are models for the highly trained, highly valuable employee who actually can move from company to company, learning more and bringing more to the companies. And I don't mean consultants. That would be a different example. I think the model of the professional as independent of larger corporations is a little bit of a more difficult fit for manufacturing, but I think it's worth at least exploring in the following way, that what you really want is the person in that position to be understanding and learning not just what his immediate job needs, his immediate company needs, but really being, if you will, an expert in that entire field and reaching out and looking at what others are doing, working with other professionals from other companies and understanding best practices as well as new practices. So I think the idea is to, part of this is to elevate it to that level where it's a body of people who really embody and create all that knowledge that represents the profession and can disseminate it back to their individual company, but are not confined to that company. One of the most disturbing things I've seen in my experience is to visit companies, large, successful, and not always successful manufacturing companies who will do a state-of-the-art study that involves looking at the state-of-the-art in each one of their factories and not beyond. And that's maybe an extreme example of what's wrong. But the idea that you can have this learning community at the same time still working for individual companies is kind of the model that we're talking about. And I'd also like to add that I sure hope that your daughter will come to
Thank you, Professor Hart. 이제 두 번째 세션이 끝날 타이밍이 됐는데요. 사실 이건우 학장님이 왜 저한테 이 두 번째 세션 사회를 맡겼을까 좀 고민을 좀 해봤습니다. 근데 두 가지가 생각났는데 하나는 제가 10여 년 전에 대한민국의 기술 대통령을 모셔야 된다. 기술 공학을 한 분이 대통령이 된다는 실언을 한번 쓴 적이 있는데 그래서 그런 거 아닌가 하는 생각이 들었는데 사실 우리가 지금 박근혜 대통령이 공대를 나왔기 때문에 그 얘기는 실현이 된 것 같은데 앞으로 남은 3년 동안에 오늘 여기서 대화는 이루어진 대화가 정부에서 좀 더 정확하게 적극적으로 받아들여져 가지고 행동을 옮겨줬으면 되게 좋지 않을까 하는 그런 기대를 해보고요. 그리고 두 번째로는 사실 오늘 제가 두 번의 그 내용을 알았다면 그 순서를 스위치시켰으면 어땠을까 하는 그런 생각을 해봅니다. 성은종 교수가 먼저 문제 제기를 하고 하트 교수가 이 MIT의 그런 Manufacturing Industry의 Master of Science 과정을 설명함으로써 한 가지 방향을 제시해 주셨다면 아주 흐름이 좋았을 것 같긴 한데요. 결국 뭐 마찬가지입니다만 저는 사실 이 공대가 여러 분야의 그러니까 예컨대 서울대학이면 서울대학, 딴 대학 마찬가지지만 여러 대학의 한 대학으로 분리되어 있다는 게 전 옛날부터 바람직하지 않다는 생각을 했어요. 그래서 제가 경영대 학장으로 있을 때 공대 학장님하고 그때 한순혁 교수님이 학장이셨는데 그 공대하고 경영대 통합 작업을 한번 하자는 제안을 해가지고 그때 한 학장님도 찬성하셨는데 그때 우리가 생각했던 세 단계는 3단계가 있었는데 첫 번째 단계는 두 대학의 학생들이 서로 상대방 과목의 모든 과목을 전공 선택으로 하자. 그래서 그건 그때 신청했었고요. 두 번째는 통합과정 또는 더블 디그리 과정을 만들자 했는데 그거는 일부만 됐었고, 세 번째는 경영대를 공대 바로 옆에 갖다 붙이자. 지역적으로 가까워야지 멀리 떨어져 있으면 아무리 많아도 잘 안 되지 않습니까? 그래서 그때 공대 쪽에서 경영대를 위해서 건물을 지어주겠다고까지 그때 얘기를 했었는데 그 세 번째 단계까지 가지 못한 게 상당히 섭섭한데요. 지금 이건우 학장님이랑 여러분께서 그런 공대하고 경영대가 뭐 물리적으로 좀 통합하는, 지역적으로 가까워지는 그런 과정을 통해서 오늘 이 나왔던 문제, 즉 이 제조업이 그동안 성공적으로 해왔지만 기존의 패러다임을 유지해가지고는 안 된다는 그런 한계의식을 느끼면서 새로운 방향으로 통합일 수도 있고 다 여러 가지 방법일 수도 있겠습니다만 그런 패러다임을 바꿀 때가 왔다는 그런 취지에 맞게 그런 변화를 이건우 학장님 꼭 이루어주시기 기대하면서 오늘 이 두 번째 세션 끝내도록 하겠습니다. 감사합니다.